Today we're going to start Chapter 12. We're going to take a look at congruence through constructions, and we're going to do that in sections 12.1 and 12.2 that we're going to do together. The first thing that we're going to talk about is what the word congruent means. So congruent means that two objects, or more than two, have the same size and shape. Same size and shape. Sometimes you'll hear it said that they have equal measure. It's another phrase. Objects are similar if they have the same shape, but not necessarily the same size. So for example, right now there's a similar object in this room. My iPad screen, right here, and what's being projected. They're the same shape. Everything on there comes through and it looks just like it does on my screen. I've got some extra tools, so ignore my extra tools up there on the top of my screen. But the objects you're seeing on the screen are the same, but the sizes are different. Okay, so those are similar objects. Congruent objects are similar because they have the feature about the same shape being true. But similar objects, like my iPad screen and the projection screen, don't have to be congruent because they might actually legitimately be different sizes. There's a couple of symbols that you need to be aware of for these particular descriptions. So when we have congruent, I guess there's two of them, so I'll write them out there that way. A congruent symbol looks like a squiggly line on top of an equal sign. That's congruent. And similar looks just like a tilde. Okay? So you almost can kind of feel like congruent means that it's similar and equal, right? Because there's those two symbols almost sort of joining together. There's a similarity to it with the symbols there. A couple other things then. Let's talk about equilateral triangles in particular as an example. Here's a diagram here on the right-hand side, and it's on your paper as well. The four smaller triangles are all congruent to each other because they're all the same shape and the same size. But they're also similar to the big outer triangle because there's the same shape. They're all equilateral triangles. But the outer triangle is twice as big as the little triangles are. So we would say that all of the triangles in this picture are similar, all of them. Some of them are actually similar and congruent even, the small ones in between, in the middle. All right, a circle. I know you guys know what a circle is, but we've got a definition for it to be very precise. A circle is a set of all points in a plane that are the same distance, that distance is called the radius, from a single point called the center. Now here's the way this works. As I give a construction in that other app, this app that I'm in right now that records an audio, it will stop. So if you go and you watch this later, you're not going to be able to see my other app show up on the screen. But if you click on video number 1 in the notes, or if you go into, there's another separate section in our Moodle Rooms classroom where it has just the construction videos, and you look at video number 1 there, you can actually see another rendition that is a YouTube video of this construction. So it won't be me, it'll be somebody else videoed, but you can still see it happening. Does that make sense? Okay, if you have concerns or questions about it, come check it out with me in my office and I'll show you how all that sort of pieces together. But we're going to actually put pause on this one, and you're going to grab your straight edge and your compass. I'm going to show you how we create a circle. All right, constructing congruent segments. There are 3 basic ways that you can construct segments that are congruent. One would be to trace, and you probably have all done some sort of tracing in the past. Maybe you use tracing paper, maybe you just used white paper on top of something else and you traced some sort of object and coloring sheet or whatever. You could trace and you could get the same length segment. Everybody agree on that? Sure. You could also measure. If you have a ruler, and I know we've got these, I keep calling them straight edges, but these rulers, you could actually say, oh look, it's exactly 2.91 centimeters long, and you could recreate it with a measurement. The third way that you can do it is with a straight edge and a compass. And that's the one we're doing. You've got a straight edge in your compass, so I'm going to show you how to create a segment when you don't or couldn't maybe measure it very easily. All right? All right, let's talk about congruent triangles. We're going to spend quite a bit of time in congruent triangles. We said before that when figures are congruent, that they have the same measure, the same size and shape. Another way of thinking about congruent figures is that two figures are congruent if it is possible to fit one into the other so that corresponding parts are congruent. Right? They've got all the same angle measure. They've got all the same side lengths. If there's a convex part, they've got a convex part in the other one. All of it matches up. For triangles, we often say corresponding parts of congruent triangles are congruent. And to abbreviate that when we want to say it, we write down CPCTC. All right? So if you see me referencing that, it's shorthand for this statement right here. Corresponding parts of congruent triangles are congruent. When we name congruent figures, we keep the vertices in order so that the congruent parts correspond. And I'll use my next slide when you have your pictures as an example. All right, so let's give these vertices some names. I will call this one A, B, C, and I'll call this one H, J, K. All right, if all sides of one, let me say this first before I actually read this slide. So on this one, if we wanted to talk about the triangles being similar, visually speaking only, not similar, excuse me, congruent, and we wanted to label them, if we went A, B, C in this one, that is if we started with A and we went clockwise, then the corresponding correct ordering here would start with H and go around clockwise. So it would be H, K, J. So that's what this is referencing over here, is that the order matters. So if you're talking about this angle B and it's in the middle, then this angle K must also be in the middle and showing that correspondence in the right order. Okay, that's what that's referencing. Okay, let's finish this slide though as it was originally created. If all sides of one triangle are congruent to the corresponding sides of the other triangle, then the triangles are congruent. So let's actually mark what it's describing. There we go. All right, so if this side is congruent to this side, and this side is congruent to this side, and this third side is congruent to this third side, then we have what this argument is referring to. All of the corresponding pairs of sides are congruent individually to one another, so we have the side-side-side congruence theorem. And we will prove this with a construction later on in this set of, I don't know if it's in this set of notes or if it's in the next set. We have another congruence. It's called side-angle side. So this would be if two sides and the included angle of one triangle are congruent to the corresponding parts of another, then the triangles are congruent. So we're going to use these sides as an example. Those sides are congruent, and these sides are congruent. Okay, so we only have two sides as it's referenced up here, right? Side and side. So I want two sides. And then the included angle. So the included angle means the angle that is formed by those two sides. It's in between them. So that's this angle in this particular argument. So if I know that those two sides and their included angle are congruent to the other one, then again, I automatically have corresponding triangles. I'm sorry, congruent triangles. Now it's worth mentioning that that's really nice in both of these cases, side, 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 and side angle side. Because what really has to be true for the triangles to be congruent is that all three sides have to be congruent to all three sides, and all three angles have to be congruent to all three angles. And what we know in either of these cases is only half of that. We don't know all 6 of those pieces of information, right? On this one, all we know is the 3 sides, and somehow that must force the angles to behave properly. That's what that's saying. And over here, I don't even know all the sides. I know 2 of the sides and I know an angle, which means I have, again, 3 missing pieces of information. But this is sufficient. It's enough to force the other angles and sides to behave properly, to be congruent to one another. Here's another one. We have the hypotenuse-leg congruence theorem. So this one says if the hypotenuse and the leg of a right triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. Now, if you'll remember, the hypotenuse is the side opposite the 90-degree angle. So this is the hypotenuse, and I've marked them. And then it can be either angle that remains. I'm sorry, either side, excuse me, that remains. So if you want, mark the bottom one, or if you want, mark the other one. Doesn't make any difference, just pick one. Now notice that this is not the same as this one over here. Yes, I have 2 sides and an angle marked, and over here I have 2 sides and an angle marked. But where is the angle on this particular triangle? It's across. It's not included between, right? The angle is not the angle that's included between the 2 sides. So this really is a different argument. It's not just like, oh, look, there's one for right triangles, look just like the other one, and we somehow made a special case out of it. It isn't. It's actually something different. All right? So knowing the hypotenuse and a pair of corresponding legs are congruent is also enough to find congruent triangles. All right, so let's do some examples. What we're going to do in these examples is to find at least one pair of congruent triangles. And we'll talk about why we believe they're congruent as well. We're not doing full-out online, like all that proofs. That's not the deal. But we'll state what are congruent and why we believe so. So if we take a look at the first picture, what triangle do you believe is congruent to what other triangle? What do you see? Okay, so ABD would be the triangle on the left. Go ahead, keep going. To CBD. Now notice I put a triangle symbol in front of the 3 letters. It's the triangle that's referenced that way. And I put the congruent symbol in between them, right? Okay, so let's actually figure out why we believe that's true. Now, one of them is marked. I've got a side marked here. That's good news. And what else do I have marked? The angle at the top. So I have a side and I have an angle. So this is not the side, side, side one, right? Side and angle. What else do I have that's maybe not marked, but it's still there? They share a side, don't they? So I'll mark it like it's something different with 2 little hash marks. They share that side there. So what of those 3 theorems that you had is actually being used here? Side, angle, side. That angle is trapped between the 2 sides that are marked congruent. So this is actually happening by side, angle, side. That's our justification for it. And that's sufficient. We're not proving it. We're just justifying why we believe they're congruent. All right, let's take a look over here in number 2. What do you see? What triangle is congruent to what other triangle? The 2 outside ones. Those are the easiest ones to see. So A, B, D, that would be outside triangle on the left. What would that correspond to? What would be the congruent triangle to that on the right? C, B, E, right? Yeah. Why? Yeah, side, side, side. They're all marked, right? Now, I want to write in one more that's there. It's more work to see. It's more work to prove, so it's not necessarily something that I'm like, you should have seen this one. That's not my goal here at all. I just want to show you that there really is one more, though, too, in case you didn't check it out when you were looking at it. Triangle ABE is congruent to triangle CBD. They overlap, actually. It's also by side, side, side. But it would be more work to prove. So let me actually draw in those 2 triangles that I'm referencing So the triangle, that's not a good color. That would work. This is one of the triangles on orange over here. And then in green, this is the other one. So you can see there's markings that match along the outside edges, right? This piece right here and this piece right here, they're congruent, right? Those are congruent pieces, the outer ones. And the inner are also congruent. We don't actually have the whole side at the bottom congruent to itself. We have a portion of it, like this piece is congruent to this piece. And because they share this one in the middle, we also get that one kind of by default, like we did in the last problem. So it's more work to see that one and to show it if you were actually to write down all your steps of why you believe it, but it is still side, side, side at play in that argument. There's two more congruence theorems. One is angle side angle. So if two angles and the included side of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. So now instead of having two sides, we have two angles. So we have this angle and this angle, say. It doesn't matter which ones I mark. And let's say I mark the top angle over here and the top angle over here. And then where does the side have to be with this argument? Between them. So it'd be this side. So angle side angle means that the side is between the two angles. And again, that must force the third angle and the other two sides to be congruent in the proper way. And our fifth one is angle angle side. So we have two angles here and a side opposite one of these two angles congruent to the other one. So again, it's supposed to be two angles, so let's get the two angles marked just like I did before. There's my two angles. And then what side could I use as being congruent if I were sort of justifying? Sure. The bottom, or it could be the right-hand side of both of them, okay? So the angles don't have the side between them on this one. That's the difference. Now, it's kind of cool to notice that what that means, these two combined together, is that it really doesn't matter where the side is. If I know two angles and I know a side, they're going to be congruent, right? If two angles and a side of one triangle are congruent to two angles and a side of another triangle, I'm good to go. It doesn't matter where the side is. Now, that was different than the one over here. Here, it really, really does matter that that angle is trapped between the two sides. It does. And the reason is, the question that comes next is, well, we've got these things that do work. What doesn't work? And in particular, there are two that don't work. The first one would be knowing three angles. So knowing three angles will get you similar triangles, but it doesn't get you congruent triangles necessarily. And you can see the argument of that on the left-hand side. Both triangles have the same three angles, but they're not congruent. The other one is a little trickier. The other one is side-side angle. And somebody along the way, imagine, told most of you that you can remember that this is the bad one because you could write it in a bad way, right? If you switch my letters around. So we're going to stick with side-side angle when we write it down, but it's not a congruence theorem that works. And the argument is actually the picture on the right, except that it needs a little bit of describing what I'm seeing, okay? So take a look at this picture on the right. What you see happening here is that they have two sides that are congruent. In particular, they both have this side at the bottom. Oh, maybe I should reference for you which two triangles I'm talking about. I'm going to be talking about this triangle here that's the obtuse triangle. And this triangle here, let me change my color. It's actually obtuse as well, but it's down here, is this triangle. The yellow, or the orange and the green. The orange triangle and the green triangle share the side AB at the bottom, right? And they also have another congruent side right here that are the same. So there are two triangles there. They have two pairs of congruent sides. And the angle that they share is angle A. They both have an angle A. So let me see if I can draw a picture of the two of them separate from each other so you can see maybe a little bit better. So that's the outer triangle ABC. And this will be my smaller triangle ADB. Okay, so they have this side, oops, I need another color. They have this side's the same, they have this side the same, and they have this one, this angle over here the same as well. So it's side, side angle. But there's no way that those triangles are the same triangle, right? They're not. In fact, one of them from the actual original picture is completely like inside of the other one. It's flat out smaller because it's actually a smaller portion of the bigger triangle to begin with. So this is an example of why side-side angle does not work. All right, we're going to take a look now. Same kind of questions we had before, but we just have more theorems now to work with. We have 3 examples, 3, 4, and 5. And for each of the following, we're going to find at least one pair of congruent triangles and tell why they're congruent. Again, we're not proving anything, we're just justifying by it's side angle side and your picture's marked to be that way, or it's hypotenuse leg, or it's angle side angle, whatever you've got. Okay, so I'd like for you to take just a few minutes, and this is the only one that I don't have marked, so let's actually mark it all together so we're actually looking at the same letters in the same places. We'll do A, B, C on the left triangle, and D, E, and F on the right one. So take a couple of minutes. I would like for you to go through all 3, 3, 4, and 5. See if you can identify the triangles that are congruent and why you believe that they are. All right, let's give it a try together with these 3. What triangles did we believe are congruent on 3? Okay, ABC and triangle DEF. Okay, are the vertices in the right order? Everybody check to make sure. Ooh, okay, so we need to fix one of them. So A would correspond to E, so E should be first, and then DF. Nice. Okay, so these are our corresponding triangles here, the ones we believe are congruent. What argument do we have for these being incongruent? Hypotenuse-leg. This is true by hypotenuse-leg. Okay, is everybody good with that one? Remember, hypotenuse-leg only works for right triangles, which this is, so that one's a good one to use for this. All right, here's another one. Congruent triangles. What do we think are congruent triangles in this one? This one's a little harder than the last one. Okay, ACB is congruent to ECD. Is everybody okay with that? Now, probably visually speaking, you believed that to be true, whether you knew how to justify it or not. There are some things marked, but there are also some things that are not marked here. So what do we see that we could use that is marked to start with? What do you see congruent pairs of? Sides. We've got a congruent pair of sides, that's good. And a congruent angle here on the edge. Now, is there anything else unmarked that you do for sure know is also congruent? The vertical angles, yeah. There's a pair of angles right here. We call those vertical angles. And vertical angles are always congruent. And we've talked about that one before, so that's a handy fact that we can use. So if we see that now, which one of our theorems applies? Angle, angle, side. I have 2 angles, the 90-degree angle and the vertical angle. I have one side, and the side is not between them. So this is done then by angle, angle, side, and it's because of vertical angles. I mean, that's the part that's the kicker, right? Without the vertical angles, we wouldn't have enough information, but because of those vertical angles, we have angle, angle, side. Okay, how about this one? This is like a arrow or something like that. What are my pair of congruent triangles here? ADB and ACE. And let me draw them in colors. So ADB would be this one because the overlap makes it kind of tricky to think about sometimes. And ACE. There's the other one. Okay, those are my congruent triangles. Okay, so knowing that then, what sides and angles help me out in that information? What do I have? Congruencies. Well, I've got a side, right? This side is marked. It's the small side in each one of those triangles that I drew before, side AB and side AE. What else do I have? The angle that's marked, right? It's an angle in each one of my triangles. So this is kind of like that last problem. I've got one side and I've got one angle. What is not marked that I also have? They share angle A, right? They actually share another angle, angle A. And again, if it helps you to draw the pictures sort of non-overlapping, these are my non-overlapping pictures. So I have this angle and this angle. I have this angle and this angle, and I have this side and I have this side. So at least seeing it like that, maybe I can identify which of the 3 or the 5 theorems is being applied then here. Which one is it? Yeah, this is by angle, side, angle, and it's because they share angle A. And I mentioned both on this one that they share angle A and on the last one that they share vertical angles because those pieces aren't marked in the pictures as they were originally given. The other pieces were. So I have no doubt you can look at that and just say, oh look, marked pieces, they're congruent. It's the other pieces, the ones that require us to sort of read behind the markings that are more important for us to make sure that we're seeing as we're working our way through.